Right. I think we can once. All right. Yeah, we can get started. Hey everyone, thanks for joining us today. Sorry, we are a bit late today by a few minutes. We had some technical difficulties. Before we jump into the session, welcome everyone to the Backend Women Who Code Backend Study Group series. We'll be recording tonight's session, and we'll save some time towards the end for Q&A. So until then, I have just set it up in a way that no one can unmute themselves to ask questions. So if you have any questions, feel free to post it in the chat at any point, and I'll bubble it up to the host. If you want to ask the questions verbally, just wait till the end, and we'll unmute folks at the end for the questions. Prachi, can you go to the next slide, please?
Yeah.
All right. So as you can see here, Women Who Code's mission is to empower women to excel in technology careers, and the vision of Women Who Code is to build a tech industry where diverse women and other minority groups thrive at all the levels, starting from an IC all the way up to the C-suite. And they're conducting a lot of series and sessions like this to achieve this vision. Today, Prachi is going to talk about how to improve your debugging skills. So before handing it off to Prachi, I'll just quickly introduce myself. My name is Harini Rajendran. I've been working as a software engineer for about 7.5, 8 years at this point, and I'm currently working with a company called as Confluent. I'm one of the backend software engineers there. I've also been volunteering with Women Who Code for about 1.5 years now, and I'm one of the leads of the San Francisco chapter of Women Who Code. So yeah, with that, I'll leave it to Prachi.
Thank you so much, Harini, and welcome everyone. I'm Prachi. I'm an instructor for the session, and I started the backend study group over a year ago, where I just teach backend engineering concepts, and I'm a senior software engineer at Tapjoy and a director with Women Who Code San Francisco for over a year now. Today's topic is about code debugging skills, as Harini mentioned, so let's just get started. I always talk a little bit about backend engineering before any session, just especially for folks who are new to our sessions. So backend engineering is anything that a front end or user doesn't see, right? So it's everything that is related to, that concerns with designing, building, and maintaining server-side web applications, as an example, right? Some of the common terms would be understanding like client-server architecture, networking, APIs, web frameworks, different platforms, microservices, databases, web fundamentals, operating systems, etc. So as you can see in the diagram to the right, the browser or your client is the front end that a user would see, and everything behind the scenes is server, databases, web applications. It's all backend. Some of the technologies that would be considered on the backend side would be, like Java language, PHP, .NET framework, C#, Ruby, Python, etc. So these are considered backend side of technologies. And some of the other domains in computer science that are, are associated or related to backend engineering would be front-end engineering, full stack, design and user experience, mobile development, DevOps engineering, machine learning, etc. So the way computer science is, these are all the subdomains, and backend is one of the subdomains. So code debugging, basically, so what is code debugging, right? In code debugging, what we essentially do is we run the code, any framework or any language that you have, you basically run the code step by step, right? So it can be every line of code that you run step by step. And why you're doing this is to understand the program flow and the flow of data, right, in your application, in the piece of code that you have written. You want to find problems in your code, so you want to find any kind of errors, you want to find any kind of exceptions. If there are any business logic issues issues, you want to look for that as well. You want to find these issues, you want to fix them, and then you want to test your code for bugs, right, or any anomalies. You also want to test functionality, right? If your application is domain heavy and you have implemented business logic, then you want to test for that functionality as well. So you do code debugging, not only to find problems and errors, but you also do code debugging to confirm that the code you have written works as expected, right? And it yields the expected results. Why it's an important skill? Because, all code has, you should always assume the code you wrote or someone else wrote, it had some kind of bug, either the bugs you introduced or it's some kind of legacy code or something else is going on. And you want to always be completely sure that your code is bug-free, right? Bug here is some kind of anomaly or some kind of error or exception that's happening. So you can safely assume all codes have some kind of bug, and for you to have a high quality, good quality code, you want your applications, you want your code to be bug free. It should work as expected without creating any kind of unexpected anomalies. Bugs can introduce serious flaws in your functionality and can cause serious side effects, sometimes expected, sometimes unexpected, and then you have to figure out that why is the issue happening and how to go about fixing it. Functionality or business logic should work as designed, right? So you have implemented some kind of business logic and you will make sure that it works as expected and you didn't end up creating more problems in your code, right? So it's very contained, it works as you designed it. Best practices for coding support bug-free development. So, like any language, any framework, there are a set of best practices or standards, and they always support for good quality code, clean code. So, they support essentially bug-free coding best practices. External integration development should be bug-free and test thoroughly. So this happens when, even if you're an individual developer or work in an organization, right? If you're doing any kind of integrations, you want to make sure that the integration is designed and developed well and it's not bug-free, because now you have external reliance on third party or some other provider or vendor or service, and you want to make sure that your code is bug-free, because if anything breaks on their side, you should be able to accommodate for these kind of things. So you want to write good quality code always. This also helps understand someone else's code, right? So if when you're debugging, let's say you join a new company and first day they are like, okay, hey, this is the project you're going to work on, start looking at the code. And well, you need to understand, right, like the quality of the code, how they have written, are there any bugs you found, or like stuff like that. So you can start with debugging to understand, right, what's exactly going on. And good debugging will help you understand someone else's code, their design thinking, program flow, and data flow. You can also do debugging to explain your code to someone, right? Sometimes you have a new grad in your team who doesn't necessarily understand the code, or it's a new technology. What you can do is you can debug the code side in front of them, and you can tell them, hey, this is how exactly things are working, right? So code debugging can also help with demonstrating your code for data flow or program flow to someone else. You can also do debugging to explain the functionalities, right? Business logic and stuff like that. And it's essential. This code debugging basically is an essential skill for engineers to do good design, to write good code, to execute quality code, and test for quality code, and contribute to continuous improvements of the code. So it's you always want to test the code you write, and how do you test it? There are different ways, but code debugging is one of the ways how you can confirm or assess, right, that everything is working as designed and as expected. So when debugging, some of the things you can do is, you have to observe some error messages or exceptions that are thrown in your code, right? So like stuff like, here I give an example, the text in red, right? It's an exception thrown because some kind of null pointer exception happened in my Java code, and it's pointing me to, exactly what file it is, what line it is, what is the error, and why. I have a variable called roots, and its value is null at that point in the program. And at that point in the program flow, data flow, the value of roots should not be null. And because it's null, it's an exception in this case, and it's throwing a my code is throwing a null point, or my program is throwing a null pointer exception. So you can look at a stack trace here and stuff like that, which will help you understand whether it's an error or exception and what does this error or exception mean, right? And then this gives me a lot of information about, the file, the line, what exactly is the problem. Now I know exactly what to do. I have to make sure that roots is not null, right? And if it's null, then why? How can I go about handling this situation, right? So I'll have to step back and understand my program and data flow. So roots is not null. This variable has a value and is the correct value expected at that point in my program, right? So null pointer exception should not be thrown. So this is a good example of, when you're debugging your code and you see any kind of error exceptions thrown, you can read the stack trace and understand what is going on, and it gives you a more specific idea of the problem. You can, when debugging, in general, you should write clean code and use best practices, because, when you're debugging your code, you can tell that there's a better way to write your code, or instead of writing something in a function in 5 lines, you could have probably done it in 2 lines and stuff like that, right? So debugging will also help you kind of optimize your code and improve your code, and it gives you an opportunity to practice basically leverage best practices of a given language or a framework. Understand that there's a dry principle, which is don't repeat yourself, which overlaps with writing clean code, where you want to not write repetitive code. If there's a repetitive code, for example, put in a function and keep on calling the function as many times as you want, right? You don't want to repeat your code. You want to don't want lengthy code, and in general, you can follow the try principles for this as well. And the other best practice here is the KISS principle, which is keep it simple, stupid. Write simple code, which is easy to read and easy to test and easy to debug, right? So you have to understand, as you debug, as you test your code, this will help you come up with, hey, start small, start simple, and work your way towards adding complications. And then you can do it in a super structured, easy to understand, simplified manner, where you understand your code, and if somebody else is reading your code or debugging your code, they also exactly understand what is going on. So the ramp-up time is much, much better. And when debugging, you usually just ask for help, right? You can ask a coworker. There's a lot of studies online, articles online, books online. It's a skill, so you have to massage it. You have to get better at it. And you can get better at debugging by writing good code, by reading someone else's code, a lot of testing and keeping on debugging, trying to break your code, trying to improve it. And it's a skill that as you practice, you will get better at it over time. Because let's say you know Python and you know how to debug in Python, but tomorrow you have to learn TypeScript, then can you even debug in TypeScript? If yes, then how do we go about it? Then what's the right tool? Or can you just add a debug, one-line debugger and do it in your local IDE, right? So stuff like that you need to understand. And the process of debugging the tools differs from language to framework. So the way I would debug in Java is not necessarily the way I would debug my front-end code, right? In my browser, it's totally different things. So it's a skill, and it differs from language to framework, and you have to understand how to learn how to get better at debugging. And some of the things that I mentioned help you start small and just get better at the skill. So how to debug code? So some examples I'm going to mention here, right? Usually developers, what they do is they would add some kind of print statement, some log statement, or print ln statement, or your alert statement if it's front-end code. And you can at one point in your program flow, data flow, see what is happening, right? Add a print statement or alert statement, and then you could see, hey, at this point, this is the value of my variable. Then I'm writing 2 lines of code to modify this value, and I'm alerting or printing again, and now I can see that my value is modified, right? So I'm able to confirm that my data is updated as expected, and my program is working as expected. So some of the small things you can do is print statements, log statements, alert statements, and these languages, the frameworks come with their own ways of doing these. Java, there's a println statement, or you can also add a logging framework or logging library in front end or PHP code, I would want to add, let's say, alert statements, right? So stuff like that you can do to see the program or data flow. In Java, there are also like statements like assert statements, right? Or basically assertions where if you look at the code I have, at the line in purple, right? I'm asserting at this point, I should not be equal to 0, right? Because I should never be equal to 0 in this loop. So I'm just asserting, making sure that for whatever reason, I is not 0, right? So like I have a for loop, it's doing something, and I'm just either printing the value of I, or I'm printing the value, the length of the word cattle in this case. I'm also logging the prefix here, which is a variable, and I'm asserting that, it's not equal, the value of I is not equal to 0. And in my output, I can see a print, and the two print statements are printing the exact values, but logger is printing much more information. So it's printing the date, timestamp, it's printing the file, and then, it's printing, and it's an info kind of a log statement, and then it's printing the value, which is cat here, right? So stuff like that. So you can use print statements, loggers, alert statements, and stuff like that to understand what is going on in your program. Pretty much, well, I would not say every IDE. I don't think VS Code has this, but I should confirm that. But like, let's say IntelliJ IDE, right? These IDEs come with Eclipse. They have their own debugger, so you can just add like you can determine at what point you want to add a debugger in your program flow, and then you can step by step or even skip your code and see what is exactly going on, the entire flow. And this can span across projects in your local IDE, and this can also span across files and different functions, right? So you can actually be able to test everything, your entire system, front and back end locally, and debug across front end, back end. And debuggers and different tools allow you to do all of this. You can see your program flow, your data flow, you can look into errors, exactly what's happening at what line the error was generated, and then it's populated further in the stack trace. You can see all of that. And this unit testing is also another way to necessarily, like debug your code or test your code. And even in unit tests, you can add debuggers and see what the test is actually doing. Is it working as expected? This helps especially when you're mocking data, or even when you're doing external integrations, you're writing like external integration tests. You can see exactly what is going on in your test, and then how to go about writing a smarter test or even a better test, right? So you can even debug your test code and then make it better. So there are a lot of different tools to debug. If you have an interior development environment like VS Code or Eclipse or IntelliJ, some of these tools provide their own debugging functionality. You just have to understand how the IDE works, and and then you should be able to leverage this functionality for sure. Basically, in these IDEs, you can add some breakpoints. Breakpoint would be a point. You basically add a breakpoint to one particular line of code in your program, and at that point the debugging will stop, and then the program running will stop, and you'll be able to see not stop, sorry, it will pause, and you'll be able to see what's the status of the data and the program flow up to that point. So you add a breakpoint, and then once you continue, now the program flow continues, and you can add as many breakpoints as you want and keep on pausing your program as many times as you want to understand the program and data flow. And you can basically, this kind of feature or functionality is a debugger in an IDE, and the debugger helps you debug your code step by step, right? And we'll see the demo, but it just helps you, basically see how smart, at every point of your program, you should be able to see what is going on. If you want to debug front-end code, TypeScript auto-detects errors and bad syntax, so it's kind of built in the framework. In the browser, you can do console.log or console.debug. Debug front-end code. If you have PHP code, you can alert statements, stuff like that. Please understand that every language, framework, or platform has its own functionality to debug, and it can be completely different. And in certain languages, there are a lot of ways to debug something. Certain languages, frameworks is quite limited. So you can't always assume that, hey, I can debug any sort of code, right? And I have all the support or tools out there. It might be limited, and you have to educate yourself on what that looks like. if you want to have, Node.js has a debugger that does code stepping and code inspection, so you get that feature or functionality. Python has a built-in debugger, which is PDB. So Python has that inbuilt, so that's like makes your life easier, right? Java has a built-in command line debugger, which is ADB. If I'm running Java code in IDE, I also get this functionality of a debugger. So now I have multiple different ways of debugging. Let's say Java code. If I add unit tests, again, I can do that too. Sentry logging prints out useful debugging information about the application, right? So it's a logger essentially, but you can leverage this logger to understand what is going on in the code, and even it can help with debugging. There are some more debuggers out there like GNU debugger, this is GDB, CodeLite for C, C++, Xcode debugger for iOS and stuff. So every language or framework has its own way of doing things. It might be different practice altogether, different tool altogether, and you'll have to educate yourself on how that works. And there's a learning curve here. Debugging as an engineer at a workplace. So if you're working on your own project, you would want to have your own way of doing things. But if you're, let's say, an engineer at a workplace in a corporate environment, working on enterprise software in teams and stuff like that, there are some of the things you can do to just get better at this skill, because this only will make you a good engineer, but as you start working with others, this thing will come in handy to kind of understand someone else's code or demonstrate what your code is doing, and really collaborate with everyone. So this skill really comes in handy, and you will get better at it with time and practice. So that's the good news. Debugging code locally for development, right? So like we need to learn debugging, because the piece of code I'm going to write, I need to debug it and make sure everything's working. I need to test it, right? So it's basic bare minimum due diligence. So that's something I need to do. So I need to learn how to debug my code, right? So that's first thing. Like I said, you need to debug to also write better tests, or even debug your tests and see that you can improve upon it. Debugging code for local integrations. Usually what we do is like we start with writing tests and writing a piece of code, which is usually a test, and then debugging through it and making sure that the integration works. Then they design and build a whole platform or an application around it, right? So you need to learn not only debugging something locally, but also external integrations and stuff like that with APIs or even other services. Debugging really comes in handy when you're fixing production bugs. There can be a production bug and you're the only engineer on call and you don't know what this bug is about, and you are assigned this task, right? What would you do? You'll have to go look at the code, debug it, and see, hey, what is going on, right? What is this piece of code? How can I go about fixing it? What is the actual problem? Is something in the business logic? Is something an error? Is something in the system failure? Is the data? There can be 5 different things that might be happening, or there can be one specific thing. Debugging will help you focus on what the problem is, and it will help you understand how to go about fixing it. Pair program with another engineer, which I mentioned, right? You can debug your code and explain to someone, hey, this is how things are happening. This is what you need to do. If someone, let's say if I'm a junior engineer and I'm putting up my code for review, right? And you as a senior engineer, like, hey, can you explain what you've done? It's slightly hard for me to understand. Can you walk through your code? One of the ways you can walk through your code is, pair program with the senior person. You can go through your code and say, hey, this is what I was thinking, this is what I've done. And then they can give you good feedback right there, right? So debugging will also help with pair programming or collaborations in general. Understanding a fellow engineer's code. We talked about this. You work in a new project, you are assigned a new service, and now your manager is like, hey, we need to add 5 new APIs here. But then what is the project about? You debug the code, you understand what is going on, and then you can, do some proof of concept, or, write some basic code to understand what is going on. And debugging will help you understand someone else's code, and even help you start a new project or a new functionality, because you can write really small piece of code and figure out what exactly needs to be done. Explain your code to fellow engineers, right? Usually in demos or presentations, you can debug your code and you can share your knowledge. Explaining application functionalities. Yes, of course, business logic and the program and data flow. When setting up a new project, debugging and running tests is the best way to learn. This is what I do usually when someone assigns a new project or I'm looking at someone else's code base. The first thing I do is I just run tests. I just debug through the code and see what is going on. lot of knowledge I gain just by doing these things. I don't go and read like, hey, how the API is written, what is the database there, stuff like that. My approach is like different. I'll run the test, I'll start debugging the code and understand what is exactly going on. Then I would be like, okay, I understand the code now. Then I'll read some documentation about it and familiarize myself with the business logic or domain side of things. So debugging really comes in handy because that's the first thing I do when I have to learn something new or someone else's code. Yeah, so I'll just, I have a Java program locally, and I'll just, basically, as I have a set of APIs, and I'll just call the APIs and see what the program or data flow is. And just, it's a really short, quick demo, but it basically demonstrates, an IDE, Java code, and how line by line I'm able to see what the data or program flow looks like. I'm going to, let me just switch to my IDE. Yeah, 1 second. Yeah, can you share my screen? Can you see my IDE?
Yeah.
Okay, great, thank you. So this is like a student application system that I have, and it has a set of APIs, database layer or service layer. And what I will do is, let's say, this is my service layer. There are a few functionalities I'm doing. I'm adding a new student. I'm getting a student by ID. I'm updating the student record and stuff like that, right? What I can do is I'll just add, so this is IntelliJ IDE, and I have like a Java microservice here. And if you see the ping dots that I added are my breakpoints where my program flow will pause. And, I can just add like a debugger here and see what is going on in my program flow, right? So let's say we want to add a student and we want to get a student by ID. So so a couple of things to keep in mind is I have my Spring Boot application here. I can either run it, then the debugger won't stop, but I need to, at the breakpoint, but I need to run my application in debug mode. This is how the IDE works with Java code. So let's say if I run my application in debug mode, it'll take a little bit because I just opened my IDE, but let's say in the meantime, I will have my Postman API tool up and running. Okay. Taking a little longer. Okay, nice and slow. Basically, it's like, making sure the code is fine. It's filling up the server, the database, and the application. So far, so good. Okay, so my application is now running. Now I'll switch to my, let me share my screen. I will switch to a different tool. So I have Postman here. I have my set of APIs to get a student, add a student, update a student, stuff like that. What I'm going to do, because we added our breakpoints in the add student program flow. Let's say I'm adding a new student to my student management service database, right? And this is, there some information. I care about their first name, their last name, the date of birth, year of enrollment, the degree, and the name of the advisor, right? So if I'm now calling the API, let's see. Okay, so let me go to the ID. So if you can see here, the call in the Postman tool is still going on. It's still not completed, but my debugger, this is a breakpoint that I added in my code, right? So my program flow has paused here. And you can see that based on you can see all the data points that we have. Like you can see the student object is created now with the first name, the last name, the date of birth, the year of enrollment, and stuff like that. Their enrollment status is null, and the student ID is not generated yet, right? So you can see that this is the data, student object is the data I got from the front end. Now, if I, step over a line, now you can see the enrollment status is set. So now student's enrollment status is enrolled. So now you can see the program flow and the data flow. Now, what I'm doing is I'm trying to save the student record to my database, right? So once I save the student record to my database, I should be able to get the student ID. And if you can see here, student ID is now generated because my database is designed in a way that every time a new student is added, its ID will be auto-generated. So ID got auto-generated, and now you have 114 as the new ID. So something happened on my business logic. Let's say this is my business logic where every new student, I'm going to set their status to enrolled by default. This is my business logic or business requirement. And this is on the database side where every time you add a new record to the database, my database is designed or table is designed in a way that it will assign the ID on its own. So now you have the student information, and if there are exceptions, they would be thrown. So now I can control, right? Like what is going on. And now I'm like, okay, I'm going to return a response to my front end, and the response is, hey, the ID and the status, right? So if I continue, my program flow ends here. And if I go back to Postman, then I can see, hey, your student was created, student record was created, and its ID is so and so, and status is enrolled. Because this is the information I want to show. So this is what I'm showing. Now, if I want to get a student by ID 114, right? 114. So then I should be able to get that student because see, I just added it and it's generated as the ID and enrolled. So basically, by adding a debugger, I was in my code, I was able to see the program flow, I was able to see how the data is being modified with every line that I've written, and this logic or this functionality or this feature that I added is working as designed, right? So in Java code with IntelliJ, I have this functionality to just debug my code and understand my program flow and data flow. Sorry, 1 second. Yeah, so yeah, I'll go back. So basically, I don't know if you can see my screen, but yeah, key takeaways. Can you see the slides? The slide for key takeaways?
No, it's just
Okay.
I can only see your Postman.
Yeah, okay, let me share. I think I shared. Okay.
Oh yeah, now it's
Yeah, so the key takeaways would be, code debugging basically is you run the code step by step. Yeah, you do it to understand the program and data flow. You can also debug to find problems in the code, errors and exceptions. Code debugging helps you find, fix, and test for bugs, also for functionality or business logic. You can fairly assume all code has bugs, and debugging helps you create quality code and constantly improve your code and make your application bug-free eventually. Debugging also helps you write clean code, use best practices, understand the existing applications, or extend your code or functionality to others. You can totally leverage IDEs, and built-in debuggers or even independent debugging tools to basically debug or improve that skill. It's essential for engineers because it really comes in handy, especially in the corporate world. And you can always, to get better at debugging, and just if you're curious, you can always, collaborate with your coworkers or read about, all these different tools and technologies and best practices to get better and better at the skill. This is the end of our session. And thank you everyone for joining. This is recorded, so this video will be available on our YouTube channel. We have 2 upcoming sessions. The next one is on November 17th, Intro to Distributed Systems, which Harini is going to lead. And our last session for this year would be on December 8th, where we'll talk about Git and version control systems. I shared some of the links and Harini shared some of the links where if you're interested in Women Who Code, you can, and our events, you can definitely refer to these links. We have a backend study group Slack channel, which Harini shared the invitation to. You can join that and you can ask questions or share your knowledge and just have a community you can collaborate with. And Harini also shared a feedback form. If you liked our sessions, do give us a shout out in the feedback form. If there are any topics you want us to cover, then do mention that, and we will do our best to come up with sessions about those topics as well. And you can also connect with Harini and I on LinkedIn. If you have any questions, now is a good time.
Yeah, if someone has any questions, can raise your hand or just ping on the chat and I'll unmute you. Oh, it looks like no questions.
I think we can stop the recording now.
Yeah.